1. So next topic is SDLC models and its phases. Software development life cycle is a framework that defines activity that are performed during software development process. Now, as we know, software development is the development of software for specific purposes. For software development, there are many programming languages that you can use, like Java, Python, C, C++, etc. Now, the entire process of this software development is not easy. If you know some programming language and just can develop a software, it's not that simple. It's a very complicated process because it requires an efficient approach from the developer in the form of the software development life cycle, because the developer should have a knowledge of every phases that is required in the software development process. That is why we use software development life cycle phases. As you can see in the diagram, also there are different phases in software development life cycle. The first phase is ideation. That means a developer should have a great ideas regarding the programming language, regarding the phases required, regarding the planning requirement, everything. He should be able to overcome all the errors, all the uncertainty, or anything if any interruption is there during the developer development process. So second is requirement. In this phase, the communication with the customer is required to collect the requirement from the customer. They are provided in a document called business requirement specification, that is BRS, and system requirement specification, that are SRS. Now here there are two terms, one is requirement and one is specification. Requirement you can link up with a client, that is it specifies that what the software must do, and specification you can link up with a developer. It specifies how the software will be created or how the software will be implemented. So it's basically SRS is derived from BRS and BRS is derived from client interaction and requirement. Now differentiating this between these two, BRS and SRS, what we can say is BRS is a formal document defining or describing a requirement provided by the client, and SRS is a document which specifies the functional and non-functional requirement of the software. As earlier I have already discussed what is functional and non-functional requirements. Now moving to the next phase, that is design phase. It has two steps, that is high level design HLD and second one low level design, that is LLD. Now any organization can directly go to high level design, or first it can go to low level design and then move forward to high level design. So let's see what is high level design. In high level design, it gives the architecture of the software product. By architecture I mean the overall design of the software. All the it all covers all the system architecture and database and designs, etc. In low level language, it describes how each and every feature in the product should work and every component. Now moving forward is the implementation or development phase. This is the most longest phase in the SDLC. This phase consists of front end, middleware, and back end. In front end, there is a development, that is coding is done, and all SEO settings are also done. SEO setting means improving the visibility of the software. Now middleware, they connect both front end and the back end, and in back end all the databases which are required in the software are created. So now moving forward to the next phase, that is testing. Testing is carried out to verify the entire system. The aim of testing is to find out the defects within the system, and also to check whether the system is running according to the requirement of the customer or not. The next phase is deployment means delivering the software to the client. After successful testing of the product, that product or a software is delivered or deployed to the client. Even client are trained how to use the given software. Now the last phase of SDLC is maintenance. Once the product has been delivered or deployed to the customer, tasks of maintenance start. As when the maintenance will start, suppose if any client or customer require any new features any new functionalities on the software, then the developer have to maintain the given software and update it according to the requirement of the client. And suppose if any errors are there, any bugs are there while using, the customer will give the feedback to the developer, and also the developer has to maintain that given software to the customer. Okay, in last slide we learned about SDLC phases. Now we will be learning about SDLC different models. We have classical waterfall model, iterative model, prototyping model, evolutionary model, spiral model, and many more. So first we will learn about classical waterfall model. Classical waterfall model is the basic development life cycle model. It is very simple but idealistic. Earlier this model was very popular, but nowadays it is not used. As it is said earlier, it is idealistic, but as you know, anything cannot be idealistic for every time. So that is why nowadays classical waterfall model is not idealistic, because the features of the waterfall model cannot be used in a real time. But it is very important, because all the other software development lifecycle models are based on this classical waterfall model. In classical waterfall models, the life cycle phases are divided into a set of phases. This model considers that one phase can be started only after the completion of the previous phase. That is, the output of one phase will be the input of your next phase. It is hence considered as a sequential flow of a waterfalls. Hence the named is classical waterfall model. Here the phases do not overlap with each other. Here in the diagram, as you can see, there are different phases of classical waterfall model. Not only classical waterfall model, these phases are very important in all software development process. So in iterative, in evolutionary models also, these same phases are used, but in a different way, obviously. So let's study about the phases which we have here. First, feasibility study, and the main goal of this phase is to determine whether it would be financially and technically feasible to develop the software. Financially means the cost of the software is appropriate to the customer, that is within their budget or not. And technically, to see whether the required hardware, whether the required software is there or not, and hence the programming language knowledge also. So in the feasibility study also involves understanding the problems and determining various possible strategies to solve those problems. Okay, now after analyzing the problems, different solutions are different solutions are portrayed, and the best solution is chosen, and all the other phases are then carried out as per this solution strategy. Okay, now the second phase is requirement analysis and specification phase. The aim of the requirement analysis and specification phase is to understand the exact requirements of the customer and document them properly. As in documentation, we already learned about BRS and SRS. This phase consists of two different activities, that is requirement gathering and analysis, and second one is requirement specification. In requirement gathering and analysis, firstly all the requirements regarding the software are gathered from the customer, and then the gathered requirement are fully analyzed. The goal of this analysis process is to remove the incompleteness means the it's not every time necessary that the customer will give you complete requirement. Means the customer can sometimes say that they just need a software to store their data. Okay, now in that it would be a incomplete requirement, because if you are storing data, that means you will use those data at any time, yes or no. So that is why it is an incomplete requirement. So the developer will analyze this kind of incompleteness also. The second is requirement specification. These analyzed requirements are documented in a software requirement specification, which we already studied about SRS. SRS document serves as a contract between development team and the customer. Any future dispute between the customers and the developers can also be settled by examining the SRS document, because in some cases it may happen that customer will claim that after delivering the product, the customer can claim that this is only half of the requirement which I have said to you, and few requirements are not being fulfilled. But with the help of those SRS, what we can see that in previously what the customer has given as a requirement. So any future dispute which can occur, that can be settled through these documents. Now third phase is design. In the design, the aim of the design phase is to transform the requirements specified in the SRS document into a structure that is suitable for implementation in some programming languages. Okay, now fourth is coding and unit testing. In coding phase, software design is translated into source code using any suitable programming language. Now this design module is coded. The aim of the unit testing phase is to check whether each module is working properly or not, because as we know, we cannot obviously code for a code for a final software at a time, yes, and also that is why that coding is divided into different modules. So when the code is divided into different modules, each module has to be tested before integration, before adding into the final software. So next is integration and system testing. Integration of different modules are undertaken. That means the modules which has been created separately, and that all the modules are integrated in one place. That is all the modules will be added in one place, and soon after that they will have a unit test also. After that unit test, they will also do the system testing also, because as we know, each module is already being unit tested in the previous phase, but now the overall testing is also required, because sometimes it can happen that the two modules cannot be run at a time. So system testing is also required in SDLC. Now when talking about testing, there are different types of testing. First is alpha testing. Alpha testing is the system testing performed by the development team. Second one is beta testing. Beta testing is the system testing performed by a friendly set of customer, not the exact customer, but friendly set of customer. Third one is acceptance testing. After the software has been delivered to the customer, to the final customer, or to the main customer, the customer will perform the acceptance testing to determine whether to accept the delivered software or to reject it. The last phase of SDLC model is lifecycle model is maintenance. Maintenance is the most important phase of a software lifecycle. The effort spent on maintenance is the 60% of the total effort spent to develop a full software. There are basically three types of maintenance, that is corrective maintenance. This type of maintenance is carried out to correct errors that were not discovered during the product development phase. Second maintenance can be a perfective maintenance. This type of maintenance is carried out to enhance the functionalities of the system based on the customer's request. In this one, it also removes the unwanted features of the customer. This third maintenance is adaptive maintenance. In adaptive maintenance, usually required for porting the software to work in a new environment, such as work on a new computer platform or with a new operating system. As we know, each and every software is not compatible with every OS, so different versions of software are required. Compatibility of a software also will be maintained. Now, in classical waterfall model, as I already said, these phases which we learned just now can only be gone through phase by phase. Like, you cannot start from design, you cannot while doing design you cannot go back to requirement. First you have to finish the feasibility study, then only after finishing the feasibility study you can go to requirement analysis and specification. All the requirements are gathered, the complete requirement are gathered, and all the analysis is done, and after doing analysis all the solutions are done, all the strategies are made. After that only then you can go to the design part, and in the same way it will move forward to the different phases. So what is the advantages of classical waterfall model? You can see here there are many advantages. Why? Because it is a simple classical waterfall model, that is, it is a very simple SDLC model. Okay, now let's go to the drawbacks of classical waterfall model. No feedback path is there, and like as you can see in the diagram, feedback you cannot until and unless you can not give a final product or a software to a customer, he or she cannot give you a feedback. Yes, so no feedback path is there. No feedback path is there, hence it is very difficult to accommodate changes request, as there is no from one phase we can only move to the second next phase only with the completion of the previous phase. So if in the middle of the development process the customers states you that in this software I also require some new features, that cannot be done in the middle of the development process. Then last one is no overlapping of phases. That means the phases cannot run simultaneously while doing designing of the software. You cannot code also. First you have to finish all the designs, then only you can do coding. So this is your classical waterfall model.